Well, you've probably been here before. If you've been using RTK for very long, it seems like your communications go out just about the time you've gotten to the very furthest, worst place on your job to get that final shot. And you get to the point after going through a long walk through difficult terrain, and you've gone over the creek and fought through the briars and the brush, and then you finally get to your point and you've got no communications. And of course, RTK depends on reliable communications from your base, getting those corrections. And if it's not getting those corrections, then you've got no RTK. Post-processing is not a new concept to GPS. In fact, it predates RTK, of course. But for those of you that are veteran users of post-processing software, you realize that there's a lot of user manipulation involved in using that software. So you've got to download your receivers, you've got to process the data. Once you finish processing the data, then you have to export those results into your survey software, and it just takes, each one of those steps just takes a lot of time. What we've done with Javad JField 2.0 is we've included post-processing software in the receiver. It actually is processing at the server, and the results are being sent back to you. So you do require an internet connection at your rover receiver, but you're able to post-process those results in the field using an internet connection. So while you may not have real-time results, you can have very near real-time results with very minimal effort. So maybe once you get to that distant point and you see that you still don't have those communications coming in, you can still log raw data at your rover, process it with the raw data being recorded at the base, and still know exactly where you were with centimeter reliability at your rover, and be able to use those results in the field in real time, or near real time. Another advantage to the Javad 2.0 software is that you can do this post-processing and get the rover results back and compare when you do have RTK. So you have an RTK solution and a post-process solution that you can compare those results in the field and see that your RTK solution was good, that you have agreement between the post-process result and the RTK. Another great thing about the post-processing feature is that you can get these results with a very small data set. I've been really impressed with the quality of results I can get with a relatively short observation time. And we'll be talking about that in this video. In this video, I'm going to be presenting some results of a test I did back in April of 2016 with a testing version of JField 2.0. So there's going to be some cosmetic changes to some of the buttons that you'll see in this video compared to what's ultimately going to be released. The reason for this so that we can get this video to you as quickly as possible. What I've done is I've set up a base on a temporary point. Actually, I set it on a concrete curb out of sight from traffic and pedestrians. And I've got a local control monument that I want to relate my project to. I'm using a 1-watt radio, and I've actually intentionally put it in a poor location close to the ground, and my control point is about 6,000 feet away. So a little bit difficult to get those corrections to this point. So I'm going to be using Hybrid RTK. First, we set up the base station using an autonomous position. Then I navigated to my control point using just the CDF, which stands for Code Float Solution, which is basically a WAS corrected or S-base corrected position. And you see that I was able to actually get within about 3 feet of the point, navigating to it. So it did work well for finding the point. And once I found it, then I began collecting. But before I did that, I wanted to make sure that I had my settings correct. So I want to make sure that I'm logging raw data and doing it in a way that I want to for success. So I press the compass button and it takes me to the new action profiles that we have available for JField 2.0. And one thing I could do is set what to record, press that, and it opens up a screen where I could select record raw GNSS at some rate. The other option is to activate post-processing option after so much time, in this case, 5 minutes. With this turned on, there's an alarm that will sound once I've had 5 minutes of raw data recorded, and I can save this file with that point. Or I can elect to discard the raw data and just store the point without it. All right, so I've pressed the start button and we see that the only thing that's really changed is the start button is changed to stop, and we see that the APP counter now starts to increment up. Now, with this screenshot, we see that it's up to 234 seconds and then 296 seconds, almost to 300. And now we're at 300, and the counter has changed from a counter to just showing depots. Now I can press stop, and before I store the point, I want to attach a photo, so I can press that attach button and take a front photo. So I bend over with the receiver camera pointed forward, and I take a picture of the monument in the ground. Now, with that control point collected, I return to my project site where I'm within the range of my RTK corrections, and I collected a few points. But now I want to do the post-processing and determine where my base is relative to the monument. So I go back to my base station, stop the base, and now use the stop and download button to download the raw data over Bluetooth from the base, which was a Triumph 2, to the Triumph LS. You want to watch that upper right button to make sure that your file is completely downloaded before you cancel or stop the download. Recording at 1 hertz or 1 epic per second builds a fairly large file, but I found that that download can be done in about 1 minute per hour recorded at the base. Now that I've got the raw data downloaded, we can go back to the home screen, press COGO, and then depots to go to the depot screen. In the depot screen, the base sessions are all shown, and I can use this filter button to restrict the screen to only show the base sessions for the current project, so I don't have to look at multiple base sessions. Next, before I press the depots button to start the processing, I want to go into the settings and make sure everything's configured the way I want. The top button performs or causes depots to or JField to send the data to depots automatically. The second option processes all points with raw data. The alternative to that would be processing only those files that are marked for post-processing, which would be from those sessions that we're using activate post-processing. The next one uses the base processing only, which means that we're only going to be processing from the base to the rover, since CORS data is not available until typically the next day. I don't want to send the file and wait for depots to report that the CORS data is not available. I know this already, So I'm going to select base processing only for right now, which will process between the base and the rover. The next option is base processing plus base shift. In this one, we get the base to rover processing. We also get the base to cores processing, which positions the base relative to the cores and then shifts everything to that base position. And then finally, we've got base processing plus cores processing plus the base shift, which works very similarly to the previous option, although it also provides cores processing to the rover positions. Now, this requires a bit of time on those rover points, probably a minimum of 15 minutes in order to get good results. So it's probably not an option that most users will use very often. Most of the time, you're going to be using those first two options, base processing or base processing plus base shift. Now we're ready to select depots, and we say yes, send to depots, and JField notifies the user throughout the process how things are progressing. Here we see that we've got 11% updated or uploaded. Now we're up to 99% uploaded, and we see the files changing from no to wait. After the files have been uploaded, now the processing at the depot server begins, and we see wait for each of our files. Once depots completes processing, the results are sent back to the LS, and we see that these files are now marked yes instead of waiting, and we see JField is now applying the post-process results. Once that's all done, we see yes, and we see that the 4 points have been base processed. We can now go to the point screen, and we see that the point screen is considerably different from what you may be accustomed to with JField 1.0. The disk icon that you see here indicates that raw data has been recorded for these points. The second column indicates the number of solutions for each point. Here we see that points S1, 2, 3, and 4 have two different solutions, one being the RTK and one being the post-process solution. If the numbers here are in blue, which these are, then they're in substantial agreement with one another, with the tolerances being set in the advanced settings in depots. If the number is in red, then the solutions are outside the defined tolerance. This makes for a very quick way to compare real-time results with processed results. JField automatically picks the best solution based on the fixed status and the number of epochs used in the solution. Here we see that JField is automatically selected for S1 and S2 to use the post-processing solution, and S3 and S4 are using the real-time solution. The user has the ability to overrule these selections done by JField, and I'll describe that here in just a moment. The final column shows the solution type for the base. So our base was started with an autonomous position, so all these all the points in this column are marked with AU for an autonomous. The blue window shows a comparison of the current selected point to all other possible solutions. Right now we have a post-processed and an RTK solution for point number 1, and it reveals very good agreement. Going to point 2, we see quite a bit more disparity between the solutions. This is because the real-time solution was based on a WASP-corrected position, whereas the post-process is an actual vector from the base to the rover. Selecting the Process Point Information button at the top right, we see even more information. We can get some more detailed statistics, and we can also make a selection to change from one solution type to the other and overrule the selection that JField makes on this. We can also select the information button at the bottom of the screen to see a detailed report of the post-processing results. We've got several utility buttons on the right side. The paperclip allows us to attach pictures and text files, text notes, audio notes to the points. The globe icon allows us to go to the review screen and center up on the point so we can see where it is in relation to the other features that we may have collected. And then the pencil button allows us to edit point details such as the antenna height and description, code, and attributes. Right now, we have our autonomous base as we had described previously. Later, if we do the mlocal or coarse processing, then the datum will be the active solution type here, and that would be green and the other would be red. Datum has actually been replaced with ABS for absolute, but basically means the same thing. Now the mlocal button found at the bottom right corner of the screen allows us to perform a shift or a translation from this particular point to a control point. So in this case, we've got S2, which was our shot that was on control 1308. I press the mlocal button at the bottom right of the point screen and recall from list, since I've imported point 1308 as a text file into my project. I can recall 1308 from the list, and now it does a translation from S2 to 1308. And we see our translation parameters at the top of the screen. And we can add multiple points to this. So if I have multiple control points that I'd tied in, I could use all of them to refine my translation. It's very important to note that you should never use mlocal to translate very large distances. So don't use this to go from, say, state plane to your 10,000, 10,000, or 5,000, 5,000 system. This is something that you should be using localization for rather than mlocal. Also note that mlocal only performs translation. It does not do any rotation. So you can add multiple points, but it's still only going to do a translation, a best fit translation of those multiple points. Mlocal replaces the previous edit base position blue button that we used to have in the base rover statistics screen. Now you can just select a base point from the points screen, select the post-processed information button as we just did, and then select mlocal and edit the coordinates in that way. And that point would then translate, and all rover points from it would also translate. Users can change the mlocal pairs as many times as is desired to find the best pair or pairs of points. And those changes can be made, and the rover points will be shifted every time. Note that after doing our mlocal, the datum is changed from red to green, indicating that it is now the current base solution type. And notice that 0 local now shows 1 local. And that's because we have one pair of points that are being used to create our translation. The base position, as you can see, is now also updated to the shifted position. So now I'm going to continue my work using the revised position of the base. So I need to return to my base setup, and this time in base rover setup, I'm going to recall the translated base position. And I'm going to recall that from list. With the base now broadcasting these revised coordinates, I can continue on to my survey work, and all rover points will be related to that new position. The next day, I was able to process the base to the cores using base shift in depots in JField. And now the solution for points S1 through S4 indicate that there are 5 available solutions. The CP in the right column indicates that the base position was determined by cores processing, and S2 is now using a base process solution with the base position from the cores rather than our M-local solution. Notice that points S5 and S6 indicate that the base position is from a known position. This is because the base for these points was started from the list. Note that base 1 is currently positioned from cores, and base 3 is positioned from the M-local shift for base 1 that we recalled from the list. I'm going to need to translate base 3 now to the new position, the cores position of base 1, in order to have everything on the same common base coordinate system. With that done, my project is completely related to a single base position, and I've also got a check into the M-local position, or I can toggle back and use the M-local if that's the desired way to work for this particular project. So that's Hybrid RTK in a nutshell. It offers a lot of powerful features, and I know that surveyors will find this feature to just be invaluable for checking their work and for also providing a positioning solution when they get outside of radio range.